Okay, good morning, everyone. In the last sessions of Unit 2 of Instrumentation and Process Control, we have learnt about various measuring instruments. Various measuring instruments like level measurement, humidity measurement, density measurement, pH measurement, and their principle of working and the construction of it and the application of the various measurement instruments, various measuring instruments. So in continuation with the unit 2 of instrumentation and process control, in this session we will learn a unit 3 of instrumentation and process control. So after learning the unit 3, one has to illustrate the principles of automatic process control and different modes of control action. So in this session, I'll cover the introduction to the automatic controller, the functions of automatic controller, then some of the examples of the automatic controllers and the references. It could be of YouTube references or the textbook references. So you all know what is process and what is control. So why automation industry? So if in any industry, if you consider, so automation is very important in an industry. Why it is very important? Whether at household level itself, we want everything to be automatic. So everything to be automatic in the sense, if you in an oven, okay, in an kitchen oven, if you set a temperature of about 70 degree, in order to cook or heat some product, it will automatically cook and it will switch off. So it reduces the manpower and the concentration in heating a particular the product or a particular vegetable or cooking a particular vegetable. So similarly, why automation in industry? So automation in industry reduces mainly the manpower. So it gives a increase in the production and it gives a qualitative production of the particular product and also the quantity of the product. So totally the automation reduces the cost involved in the production of a particular product in any industry or in any process or the operation is considered. So that's why the automation in industry is very necessary. So when it in an industry, in order to run a particular process, we have to have instruments. Okay, the process of using the instruments based on our requirement, we call it as instrumentation. So instrumentation includes sensors like measuring instrument, transmitters, visual displays, recorders, automatic controllers, which have been designed to meet the purpose of the process. So in that, if you consider any particular process, in order to achieve a qualitative product, the controller is the main element in any instruments. So when the controller manages itself the variable to the required or the set point, then we call it as an automatic controller. So automatic controller is what? It is a device which is being used to maintain the process variable value. So the process variable value could be of temperature, density, viscosity, pressure, all that, the specific gravity or the humidity, whatever it is, the process variable value at the desired range or the set value is called the controller. When this device has been designed to do the job of controlling the variable by itself, then we call it as an automatic controller. So the controller which controls the variable by itself, then we call it as an automatic controller. So what is a process then? So process is, it is a physical or the chemical change of matter by converting the energy by itself. So the process is, we put a raw material, the process will go on in order to achieve a particular product by either converting one form to another form. So converting the energy by itself. It signifies the functions and the operations utilized in the treatment of the material. So what are the functions are involved? What are the operations are utilized in order to reach a particular product from a raw material? All will be included in a process. What is a system then? System is nothing but any particular instruments, if you take the combination of all the components that act together to perform a certain objective within the limits, we call it as a system. So for example, as we were speaking about in the kitchen, the oven. So oven has got this starting point and the ending point, start, set point, everything it has got. So the combination of all the components in the oven that act together to perform a certain objective within the limits. So that we call it as a system. The oven is a system example, we can say. So washing machine is a system, refrigerator is a system, where you find the number of components that act together to form a certain objective. So that is being set within the limits. In the refrigerator also, you will be setting the freezing point, all that. So what is a disturbance? So the disturbance is when the signal which tends to affect adversely the value of the output of the system. It can be inside the system or outside the system. So inside the system maybe some default in the components of the particular instruments. Outside the system in the sense it may be any process variable. It could be of pressure, temperature, the specific gravity, viscosity or the density, etc. So it is some sort of a disturbance to a system which adversely affects the output value of the system. So that's why we say that it could be of inside the system or outside the system. So what is a process variable? So process variable could be of temperature, the pressure, the viscosity or the flow or the level or the pitch or the pH, sorry. Many internal and external conditions affect the performance of the process. So that we call it as a process variable. What is the state of the process? State refers to the condition of the process. So condition in the sense the specific value of the process variable which exists within the process. It is nothing but the specific value. For example, temperature. If you have the system, for example, any heating system has to be in which the temperature has to be maintained 70 degree, in the sense state is 70 degree. So the 70 degree could be in any state, any phase. So that is the specific value of the process variable. Example, temperature 70 degree, pressure some centimeter kg per centimeter square. So all that represents the specific value of the process variable which exists within the process. So these are the certain the points you need to know before going to what is automatic control, what are the different types of automatic control, what are the functions of the automatic controller, what are the different types of the automatic controller system. So before going to further of all these, you need to have a thorough understanding of what is automatic controller, what is the process, what is the system, what is the disturbance, what is the process variable, what is the state of the process. So in further sessions or in further classes, if you if any term like the process variable or the state of the process or the disturbance of the system comes, you should immediately have an idea what it is. Then only you can understand thoroughly. So what are the functions of automatic controller? So it receives the actual measured value of the variable to be controlled in any particular control system, and it compares the measured value with the reference of the set value. So determines the magnitude or direction of any error or the changes, in which way the error has to be corrected, or what is the cause for the error to occur. So what is the magnitude of the direction of the error? All that is being determined by the automatic controller. So and also automatic controller provides an output signal as some function of the deviation which will reduce the error to a smaller value. So automatic controller, it always tries to reduce the error to a smaller value. So these are the functions of an automatic controller. So let us look into some of the now you have understood what is an automatic control, what are the terms involved in automatic control in order to understand what exactly the automatic control system is. So let us look into some of the examples of the automatic control system. Here you can see some home heating system. You can observe here you have a furnace and you have a home and you have a regulator. The regulator, the signal, you can see signal is being interconnected to the valve and again into the flue gas flow, again to the furnace. Home, again to the furnace. Here the flue gas, the fuel gas flows through the valve, to a furnace which burns to generate a hot air or the steam. This generated hot air or the steam is used to heat the home so that whatever the temperature we require is maintained at a comfortable temperature. If the temperature of the room is measured by an instrument and it is set for the desired value, it measures the temperature of the home, which is being heated by the fuel gas, and again the fuel gas is in turn heated by the furnace to provide the hot air or the steam. So whatever the temperature we have measured by the temperature measuring instruments is being compared with the set point. And if any error, if for example if the set point is around 70 degree, the temperature is to be maintained around home heating system usually in cold countries it will be required around 25 degrees centigrade if you want to have the temperature inside the room about 25 degrees centigrade. If it crosses beyond the 25 degrees centigrade, okay, it's the signal, the regulator sends the signal to the final control element or the controller. Okay, so it compares the output value from the temperature measuring system with the set point of 25 degrees centigrade. So if the error is of +1 and it crosses beyond the set point, then the valve is closed automatically and the fuel gas flow to the furnace is also automatically stopped, and further no hot air is being sent into the home for heating purpose. If it is less than 25 degrees centigrade, the output value which is measured by the temperature measuring instrument, which is less than 25 degrees centigrade, again the signal is being sent into the final control element or the controller in order to open the valve. In order to open the valve, to send the fuel gas to the furnace. So again the fuel gas will be heated and the hot air will be sent to the home and the required temperature is being maintained, and again the temperature measuring system will measure the temperature until the output value of the controller reaches the set point, which we want the temperature of the home room heating or the home heating to about 25 degrees centigrade. This is how the automatic controller operates. The example of home heating system. So let us look into one more example, the temperature control in exothermic reactor system. So here you can see the jacket is being provided around the reactor, wherein the cooling fluid, the cold fluid or the cooling fluid will be sent inside the jacket and the cooling fluid out, and the temperature of the reactor is being maintained. And whatever the reaction which is going on in a reactor is an exothermic reaction, okay, where the heat is being released. So whatever the heat is being generated, which will be measured by the temperature instrument controller, okay, temperature indicating controller. So which measures the temperature inside the reactor. So if it crosses beyond, for example, if you think the temperature has to be maintained inside the reactor is about 70 degrees centigrade, it measures the temperature And if it is beyond the 70 degree temperature, it will be indicated by temperature indicator in controller, and the signal is being sent to the final control element. So if it is beyond the 70 degree, then automatically the control valve will be closed, so that control valve will be beyond, in the sense the control valve will be opened, so that there will be a flow of the cold fluid inside the jacket in order to cool the reactor, so that the temperature is being reduced. So here we have, that's why we have shown cooling fluid in and the cooling fluid out. So if the temperature is less than the required temperature, about 70 degree centigrade, which has to be maintained inside the reactor, then again it is being, the temperature inside the reactor is being maintained, measured by the TIC, and the signal is being sent to the final control element, thereby opening the valve of the final control element, so that the cold fluid will flow inside the jacket in order to control the temperature inside the reactor. Simply we can say that if it is beyond the set point of about 70 degrees centigrade, so it automatically opens, the control valve will open or automatically opens to send the cold fluid inside the jacket. If it is less than the 70 degree or the required temperature, then it automatically closes. So this is how the temperature control in exothermic reactor system can be controlled by using an automatic controller system. So next we can see the temperature control in an endothermic reactor. So that could be of steam heating or electrical heating. So by this, having understood by these two examples, I think you have got an idea how exactly the any parameter, any process variable can be controlled automatically. So temperature control in an endothermic reactor, you can see the temperature is being absorbed here. The heat is being absorbed in an endothermic reaction. Exothermic reaction is nothing but here the heat is being released during the reaction. Here the heat will be absorbed in order to have a reaction. So you can see so you are sending the steam in, okay, through the coil, and the steam out here, and the feed, then the stirrer, the temperature indicator TIC is being provided inside the reactor, and the product, the signal is again being sent to the final control element in order to open the valve or close the valve based on the set point, which crosses beyond the set point or less than the set point. So here again, here it is the temperature control is being done by means of a steam. Here it is being done by means of electrical heating by electrical heater. So the temperature control in a water heater by changing the heat flow, you can see. So if you want, for example, is temperature control in a water heater by changing the heat flow. Here you can see the water heater. This is the temperature instrument. Then you have a controller, heat flow, cold water in, hot water. So if you want a constant temperature, hot water at a constant temperature, at a constant flow rate, you require to maintain the heat flow inside the water heater. Okay. So the temperature inside the water heater is being measured by the controller, TIC. Again, same with the, if it is beyond the set point, automatically the flow of heat to the temperature water heater will be cut off. If it is less than the required temperature, constant temperature, then there will be here the final control element will open, and the heat flow will be to the water heater in order to heat the water to the required temperature. So that's why we have shown the cold water in and the hot water temperature measurement, and the controller, and the water heater. So another example is how can we control the temperature in a heat exchanger. You can see the hot fluid in and the hot fluid out maintain the temperature of the hot water in a heat exchanger. Heat exchanger, here the cold fluid in and the cold fluid out. So the hot fluid is being sent through the heat exchanger. These are the tubes inside the heat exchanger. And the temperature of the hot water is being measured. And again the measuring instrument, hot fluid is being measured. Here you can see measuring instrument, and the controller, if it crosses beyond or less than the required set point, it gives a signal to the valve either to close the valve or to operate the valve based on maximum or the minimum value of the temperature value of the hot fluid with reference to set point. So these are some of the advantages which we have looked into. Home heating systems, temperature control in exothermic reactor systems, temperature control in endothermic reactor systems, and the temperature control in water heater by changing the heat flow, and also finally the temperature control in a heat exchanger. So what are the advantages of, let's look into what are the advantages of automatic controls. So by having understood the examples, I think you've got an idea what would be the advantages of automatic controller. It improves the quality of the products, right? Yes, it improves the quality of the product, and also it increases the quantity or the number of products. Improves the uniformity of the process or the number of products. So it also improves the uniformity of the process and the products. So uniformity of any process or the products can be achieved by use of an automatic control. The process material can be saved by using an automatic control system. And energy requirement in order to run a particular process also could be saved by use of an automatic control. So the plant equipment, the use of a plant, number of the plant equipments, the equipments in any plant can also be reduced. So again, we can, by use of an automatic control, human error also can be decreased. Overall, by use of an automatic control, economic system maintained balancedly in any particular process. So overall we can say quality, quantity, uniformity of the process, savings in the process material, energy requirement is also being reduced, and the equipments which are being required to run a particular process can also be saved, and we can reduce the manual error can be reduced, and manpower also can be reduced, and the overall economic balance of any particular process can also be maintained. So these are the various advantages of automatic control. I hope you have understood various examples of automatic control and what is automatic control, what are the various elements which are being used in automatic control, and the advantages of automatic control. For the references, you can go through these books: Instrumental Method of Chemical Analysis by B.K. Sharma, then Instrumentation and Process Control by R.P. Vass, and the Process Control by Harriet, Instrumentation and Process Control by A.P. Kulkarni. I hope you have understood by this section of automatic control. Thank you.